Would you like to do your presentation now, sir?
Sure. Yeah. Sorry, I was starting to be angry here, so I started cooking.
No problem. It's, you know, it's been a long day. I'm actually making dinner for my child in the other room. That's why I keep running away. But
yeah. So yeah, I like the APEC section because you know my presentations are usually short and very consistent. So so that's why I prefer to ask to be in the APEC section. So yeah, I'll just go ahead.
yeah, let's do that. Mark, you guys are all wrapped up, right?
Yeah, pretty much.
Okay. Well, let's do that. Yeah, this is a big day today. Get a lot going on today, but that's awesome. This is like classic APEC. So.
Oh, by the way, thanks for the heads up on the metal 3D printer. That's pretty awesome. I thought that 3D printers would work only for plastic, but no, it works for metal. That's really awesome. So thanks for the heads up on that.
Yeah, so Phil, I have you all set up. You were spotlighted. I can see your screen. It looks great. So I would say, you know, go ahead, sir, and just let me know when you're done.
All right. I'll just do a little update on whatever. I know a lot of people know already about that software I wrote. I just want to make sure that everybody knows, and then I'll move on to the TR3B subject. So that's the microgal. That's a software I wrote on GitHub that computes the Earth's tides. It compares the theoretical values with the experimental ones. There's a residual that is found, and it's very similar to the derivative, to the normalized derivative of the theoretical value that we should get using by measuring the Earth's tides. The Earth's tides, by the way, is when the Earth rotates. It aligns with the sun at noon and at midnight, but at 6 in the a.m. in the morning, 6 p.m. in the afternoon, then it's going to be perpendicular. So there's a preferred velocity, there's a preferred direction here we measure. So that clearly points out that there is some ether wind or a superimposed co-moving gravitational layers in place. So it's pretty obvious at this point that that there is something, obviously. So, and also as I was saying quickly in the APEC forum, you know, the location of a white hole, how do we determine that? The black holes really are aggregate, like it was proven last year, so there's no singularity or wormhole, which, by the way, relativity relies on, because because space needs to go somewhere according to relativity, so it kind of refutes relativity here. And also the gravitational redshift that is kind of mutually exclusive with the locality of relativity. So here, there's a whole bunch of facts. I had a proposal for the ISS, for an experiment on the ISS that was basically the Michelson-Morley experiment aboard the ISS, but I'm not sure if it's worth it to perform it anymore, because all the theories, you know, I have refutes relativity. So I'm gonna move on to the fun stuff. Just 1 second. Yeah. Here we go. Okay, gravitomagnetism in the TR3B. So if we take the measurement units of the virtual particles, the electric, the magnetic, the gravitoelectric, and the gravitomagnetic, it comes down to this. If you simplify all the mathematics, it comes down to this. And the gravitomagnetic particle is actually the simplest one. It's measured in hertz. So clearly, it's pretty obvious that the only thing it can affect is time. So if you have a virtual particle that travels around and it's going to modify the time, which means you can modify the speed or the acceleration of a projectile or anything you want. So that it's kind of the root of all the other particles. And also yeah, so also since we can, it's dipole, gravitoelectric, which is gravity is monopole, so that's why it's a force that can only be superimposed and added, and so on. And now, if we move on to the magnetic field, this is a standard magnet. This is a current loop that generates a magnetic field, which is the same thing as a gravitomagnetic field. And since I just said that the gravitomagnetic virtual particle modifies the time, then you can actually it's possible to find a way to mold the lines of force here to modify the time in such a way that you have some sort of force field, a force field that slows down projectiles going at you. You can also create a tunnel with the walls being made out of virtual gravitomagnetism, the virtual particles. So if you create the walls using that, then you're gonna stop all the other particles, which include gravity, which means you can lower the gravitational potential in it, which means you can travel faster than light. So the only requirements I'm not sure there is if gravitomagnetism, I'm not sure about the speed of gravitomagnetism. Obviously, if it's the underlying force, so if it's faster than c, then we could create that tunnel on the fly. So I'm pretty sure it is, because it's really the underlying particle here, but I'm not sure yet. I'm not 100% sure. So basically, you have a starship, you can create a force field and a faster than light tunnel. And this is the experiment I already done, the spinning disk experiment that I did that was successful. According to a certain RPM, you get some gravitational acceleration shift according to a certain distance. And my next experiment is going to be slightly different. It's going to be based on a cyclotron. That's going to confirm for sure that we're using professional equipment and lab equipment, that we have the right measurements. And also Also, it's also possible to do that using liquid metal vortex, which basically can be can be done using magneto-hydrodynamics. You can make liquid metal spin very fast, and yeah. So according to a certain velocity, it's going to create a gravitational acceleration shift. But the nice thing is you can stack up the vortices to add up the acceleration shift. So if you have a vortex that creates 7 meters per second squared, then you stack 2 up, then you get 14 meters per second square, which is already higher than 9.8 meters per second squared, which will create anti-gravity very quickly. And yeah, that's basically what the TR3B is. It's a gravito-magnetism generated using magneto-hydrodynamics very intensively. So that's all that it can be. It's either a plasma or a liquid metal, but plasma is probably what they use because it needs to go very fast. I have like you say, like you just say, so I have all the calculation. They're undisclosed. The secret sauce still is undisclosed because I'm looking for VCs. But that's the big picture. That's what the TR3B can only be. So yeah. So that's my short and consistent presentation I wanted to share with you, and that's about it. So yeah, thanks for your time. I really appreciate.
Yeah, absolutely. Well, everybody, here, let me put this thing back on speaker view. Everybody, let's give a giant applause to Phil Bouchard. Sir, thank you. Thank you for the impromptu presentation. Thank you for the update on your research. That is awesome, man.
Yeah, thanks. It's and thanks for the forum. I debate some things. There's a lot of emotion sometimes. Debate some things, but the conclusions I got out of it, it's very very valuable, and it's everything I said at the beginning is everything I learned on the forum. So thanks a lot for that. I really appreciate.
Oh yeah, absolutely. Well, on that note, let's go to open discussion. Everybody, open discussion, no holds barred. So you know what, in the background there, I see, actually, I should see if Tony wants to tell me about.
Question for you. How do you, what are your assumptions about measuring the gravito-magnetic components in your experiments? Can you expand on that?
My assumptions, well, it's based on the first experiment, the spinning disk I did in October of last year, that confirms my calculations. Now I'm just scaling it up. That's all I'm doing, using a cyclotron and a vortex, a liquid metal vortex.
What equipment do you use to make the measurement of the gravito-magnetic forces, their components?
For the spinning disk, I just use my own cell phone. There's a gravimeter in it already you can use. Mm-hmm. But for the cyclotron, we're going to use a professional gravimeter. To confirm that my cell phone is not misleading us.
Oh, okay. Okay, so you made some theoretical prediction about the gravito-magnetic component, and then you measure it?
Yeah, exactly. And I did try the the spinning widget, the fidget spinner, sorry. It didn't go very fast using a compressed air. That didn't work. It didn't go that far with that, but the week after, I was able to measure something with the spinning disc. So it's an engine. Obviously, I didn't make it on my own, but it's an engine that spins very fast. So yeah, so we're scaling it up right now, and we're looking for VCs. So yeah, I know that I'm still trying to understand. You know, I know you modify time and things like that using gravitomagnetism. That's why it fits very easily with finite theory, because it's based on time dilation, time contraction only.
Mhm.
And but they're still trying to figure things out down at the quantum level. You know, I measured it experimentally, but I did not derive it. So there's still some work to do. I need to do some work that needs to be done on the derivation side. But other than that, I'm all set, basically.
How are you separating that? On the one side, you're measuring gravity, and the other side, magnetism, you know, and it's not that one is confusing with the other. I mean, how are you separating that you are measuring the true components of each one and the gravitomagnetic component? Are you separate and then measure together, you know, or are they all three? You know, you one gravitomagnetism come together, you measure, and then you measure gravity, and then you measure the magnetic component. Are you taking measurement all three at the same time, or just two of them?
So I made sure that my cell phone was not affected by the magnetic field, and that's why the cell phone. You know, if you get the cell phone close to a monitor or anything electronic, it's not going to shift. It's not going to affect the measurement. So that's why I know that the only thing you can measure is the gravity. So that's. But you know, there's still room for errors. But now I'm going to use a real gravimeter
Oh,
shield
okay.
for the cyclotron experiment.
Oh, okay. Now that things become clearer now. Hey, thank you. Good experiment you have there, and keep on making progress. Thank you.
Yeah, I'll give updates here and then.
So hi. So I just had a question. So using gravitomagnetism via MHD to generate thrust, is that what it is?
Yeah, it
Or
creates
are you doing anti-gravity? Like what? Just kind of curious about that.
Yeah, it creates an acceleration vector.
Okay.
Depending on the either if it's clockwise or counterclockwise, it's going to create an acceleration vector, and if it's greater than 9.8, then you're going to fly.
Okay. Yeah, because the reason I was curious about it, because I know gravitomagnetism has it's quite. I think it's been measured as very low. So is it something that you've been able to accelerate it, or somehow using MHD? Is that what?
Yeah, it's the theory says that it's 10 to the minus 27, something like that.
Yeah.
The theory was done by analogy, not by derivation.
Okay.
So it's a wild guess, and apparently it's not right. So by a large factor.
Oh, I see. That's interesting. Okay. Yeah, that would be excellent then if the difference is from 10 raised to minus 27 to much higher, then yeah, that's a tremendous advance then. Yeah.
Yeah.
One more question. Have you done the experiment, just to get data comparison with the disk spinning horizontal and then you put it vertical? Because on the vertical disk, you would have the additional, the gravity produced component of the gyroscopic force. Have you done it at like, for example, this vertical, horizontal, and then in between to see what are the differences? And you can isolate all the component from the data.
Yeah, you mean 45 degrees and 90 degrees and all that?
At 0 degree, exactly.
Yeah, no, I just did it vertically. Well, I mean
Okay.
the horizontal plane and
Uh-huh.
the gravimeter on top of it.
Oh,
But
okay.
I could have done it 45 degrees and then compared the theory with the experiment, I guess.
The gyroscopic force produced when you had it vertical at 90 degrees, parallel to the gravity vector, the disk, the gyroscopic force, the spinning disk produced, agree with your data on the gyroscopic force, what it would be if, for example, that if it is not restrained, it would produce precession. But I imagine you have a disk restrained, so you cannot produce precession. So is that how you did it? With the disk rigid so that there will not be any precession, but you can measure the gyroscopic force, or just, how was it?
Yeah, 1 second. I'm just gonna turn off the oven. Yeah, sorry about that.
Okay,
So, sorry, I don't understand really the question.
okay. What I was asking, since you did the disc spinning vertical, did you have it rigid that it will not move? Because if you have a disc spinning vertical, there will be a gravity-induced gyroscopic force that can cause the precession of the disc if the whole device was free to rotate. Do you do it, that it was not able to rotate? And do you measure any force, on gyroscopic induced force at, let's say, the 90-degree position, horizontal force on the disc?
Yeah, no, I didn't measure directly any force directly on the disc. It's kind of a they don't have control of the speed or anything like that. I just know it was going at a certain speed, but I didn't measure the precession or anything like that.
Well, it was rigid, it was fixed, that it will not move.
Yeah,
Because if it was fixed, you cannot measure any precession.
Yeah, exactly. It was fixed.
Oh, okay. All right. Okay. That make it clear. Thank you.
Yeah, no problem. So yeah, and like I was saying, if you get the right speed and you stack up the vortices, then you're gonna get anti-gravity very quickly. So yes, that's a cool thing. It's it's easy to scale up. So it's unfortunate. Is Jared still here?
Yeah, I'm here. I was wondering, I know you have the Mercury. I read, there's a lot of prediction about the Mercury, and I've seen a lot of the video about the Mercury. I know many years ago I did Mercury experiment, that thing turned out to be very good, except, just get it spinning. But what you're doing, since you were measuring any anti-gravity effect, especially on the spinning, and that's a part that I'm curious about, what is you know, the result when you have a spinning a high speed, because I imagine the higher the speed, to make the mercury spin faster, you probably have to you need a very strong magnetic field and also an input of current, you know, electric current, to make sure that it speed up a lot more. And so there should be some component there, a gravity and anti-gravity component, something that I still see a lot of debate, you know, many people predict it will be there, but I have not seen any accurate data. And it looked like you are giving more than everybody else is giving, because you at least you have some data. You have make some educated guesses what it would be, and you're producing something. And that makes your experiment much more interesting and much more important to clarify the whole subject, whether it does or does not produce anti-gravity wave, the spinning, the vortex of Mercury.
Yeah, I got the data. I'm pretty happy to learn that we can 3D print metals. So I'm gonna do the apparatus, the vortex, the third experiment very easily now. So yeah, that's awesome. That's really cool. Wasn't sure because for the magneto-hydrodynamics, you need metal mixed with wood or plastic, something like that. So just calculated that within maybe within an hour you can get a speed high enough, either using mercury. I would prefer using gallium, but we can measure a difference, a gravity shift within an hour. So that's pretty cool. You just spin it up. At some point, it gets so fast that you can measure a gravity shift.
Oh, Phil, I left the spotlight on you, sir. So it has been on you for the last 25 minutes. I just removed that, so it's still on you as long as you're the one talking, right? But
one more question: have you considered doing the same experiment with ferrofluid?
I wanted to. I was thinking about it using a toroid, but apparently I ran a simulator. I can forward you the link of the simulator. It's a cool website that have a plenty of JavaScript online simulators, and you see that the ferrofluid inside of the toroid is gonna move randomly. It's not gonna move according to the magnetic field inside. It's gonna spin, it's gonna rotate, and the particles are gonna spin on their own. They're not gonna spin in circle. So that's a very, very nice website. I already posted it on the APEC forum on WhatsApp, but I can forward you the link if you give me your email address. Are you on mute? I can't hear anybody.
I will send you the email.
Yeah, okay. Yeah, I see a comment here. The density of mercury is a little bit different than gallium. I know that gallium is slightly less dense, but still pretty. Still is pretty dense. The density is pretty acceptable. All right.
Okay, I put the email there.
All right, I'm just gonna.
Actually, Charles Crawford is here. He wanted to present. Hey, Charlie.
Sure. Hello, hi, everyone.
Hey, Charles.
I can give a quick update of the Graviton. So I've been testing it for about 6 months now, and recently I have been pretty busy, so I haven't had as much time as I wanted to, and so has Todd Desiato. But we've been both looking at it from different directions, and yeah, I got the first kit from Alex Chekrikov, So I replaced the center disc because when he shipped it, it was bent. And he's all the second kit has also been shipped. Most of 2 out of 3 packages. So I'll be helping with reconstruction of that kit and testing. Hopefully, if I could fly down to meet Russell to work on that. And yeah, we've been comparing notes because there's some changes in the second kit that's different than the first one. And I've been asking Alexi for more detailed tuning instructions. So, with each test, I get a little bit better at learning how to tune it. And I haven't noticed any lift or anything unusual yet, but hopefully before the end of this year, we'll be able to confirm or deny that it lifts or not. Still looking pretty promising. So I've got all the circuits working and I've reproduced a lot of them. Let's start here. The Tesla coil, which was one of the original he showed in the videos. Make it too shaky. I've replaced some of the transistors, added some 12-volt fans to cool it down. And that's the original coil he sent me. And I've reproduced his ultrasonic sensor. This is the one he sent me. And this is the circuit on the little proto board. And this is the high voltage circuit he sent me in that container. And I've reproduced 3 of those with these 3 flyback transformers, and also got another equivalent high voltage circuit. And I've, of course, reproduced the Tesla coil designs. It's just a Slayer exciter Tesla coil. And these are just with 1 transistor, 2 transistors in series there. And yeah, that's basically it. I've also tried to make a faster spinning one with a larger motor here. So there's some improvements to this gravel flyer frame design. There's acrylic arms instead of the aluminum, so they won't short to ground because these legs are connected to the center plate, which has AC on it and touching the ground there. So the high voltage on the plate will want to jump down or across there. So with these faster motors, though, I'm able to spin at higher RPMs, see if that makes any difference. And Mark has helped me CNC cut some of these discs so that they're less wobbly than the hand cut ones Alex has been using. And I was able to find and kind of reverse engineer the rest of the designs. So I put that online and on Facebook, on my Facebook, and on the American Anti-Gravity Facebook. So I'll keep trying different variations of it, see if that makes any improvements on it. But yeah, still testing myself and using this neon bulb and oscilloscopes and other sensors, high voltage probes, making sure it works, and some other Tesla coil designs. And this signal generator for the ultrasound, the variations on that. But yeah, again, I haven't noticed anything different. One big thing I did notice that was a mistake on my part was getting these cheap converters from a European outlet to an American adapter. By doing it that way, I'm not actually getting the voltage adapt like the 220 volts I need. So I'm getting a different converter box that'll convert the voltage, hopefully. But I've also got the car battery. I've been testing with that for a while, and this will be easier, I think, to test rather than getting all the adapters and all that for the European power. And yeah, that's about it for me. That's the updates for Gravify.
One question, when you're spinning the disk, have you done any experiment, for example, if you keep the voltage constant and you spin the disk at different RPM, are you getting any kind of voltage variation, voltage differential between the 2 plates when the spinning, as a function of RPM?
Yeah, well, as it spins, I haven't noticed any voltage change on the plates, but I'll make sure they're charged by using a shorting wire or a high voltage probe. And I've adjusted the height and distance between the plates. So Alex Turkoff said that's one of the difficult parameters of adjusting on this, where you need this distance to be precise and the distance here between the center plates be unique as well. So I've been trying different heights for those as well.
But do you get a voltage variation as a function of RPM when the disk is spinning, or is it remain constant?
It remains constant. Yeah, unless it shorts to the frame or to the center plate, the voltage on them remains the same.
Oh, okay.
Yeah, it's about as Alex Chekhov wrote on the high voltage kit, it was about 20,000 volts.
Okay. I mean, we're only suspended animation waiting for us to see you make that thing fly.
Okay, thanks. Yeah, I'll keep trying.
So we're being suspended animation until it happens. I hope you make it happen soon.
Thanks.
That way you eliminate all the waiting.
Yeah, me
Good
too.
work. Good work. Thank you.
You're welcome. Thanks.
So what new have you learned from it? You know, tell us from what the experiment you have you done some experiment, or are you going to do new experiments, test something new and different to get closer to that goal? What is it?
Yeah, I've learned more about the Sayer exciter Tesla coil design, electronics, learn more about the ultrasound circuit. I found it interesting that Alex wrapped his own transformer from an inductor. So I thought that was something they don't teach us in school, even though I'm a PhD student in electrical engineering. He was pretty creative with that. And of course, I was able to reproduce all his circuits. Here's his gravitometer, he's calling it, to help measure the fields around it. So I reproduced that. I made a copy of this and gave that to Mark. He has one like this. So he's using an analog high voltage meter to measure the fields around it. It's pretty clever. So yeah, each part of the circuit and the gravifier is pretty interesting.
Are you measuring the gravitomagnetic effect on that particular equipment?
Just basic voltage potentials from oscilloscope, and this meter is measuring like the high voltage fields around it. It'll light up better green.
Oh, okay. All right, cool, super cool.
Thanks. Yeah, here's the original Alex Chekhov design there.
Cable is 18 inches deep, 16 inches wide. Fits into that tape. So fits in perfectly in that space.
Well, your buddy's a fucking ignorant hillbilly sometimes. Just remember that. Oh, gosh.
Oh.
With my...
Hey, Charlie.
Hey.
So you're not going to show us the coil?
Can't show the coil. Why? Why not?
I can't. Well, I was asked not to.
Oh, well, how does he get watched? He's in Portugal still?
Well, until we could, get permission to share that other coil, that'd be good. Or if we could verify it ourselves independently, that would be good too. I know Todd's kind of shifted gears too. He's not working on the gravifier as much, he's working on the coil.
Yeah, life bit him in the ass too. He's got to deal with some stuff not pertaining to propulsion. It's called life in general. So, oh, cool. Let's find the frequency. What's the liftoff frequency? Come on, give it away. Spill the beans. Make it fly.
Yeah, that's the trick.
Is it? There's got to be a feel to it. Fred, let's fly it up to Hutchinson, and maybe he can like do some Hutchinson effect on it.
Maybe. Yeah, we can maybe visit Hutchinson. He's going to be working on his setup again, hopefully in summer. He'll have better internet connection. His house will be complete, and he'll start demoing some of his effects again. He even showed a micro effect where a wire kind of exploded while he was testing a few weeks ago. I don't know if you saw that.
Floating wire. Sorry, the compressor's on. So, oh, the floating wire, or
No,
he made it like it just turned into butter. It crumbled and it fell in on itself. It manifests some strange effects with metal. So I could only see it. I remember it vividly. Like I was, sober down at UNM, locked up in the basement of the business library, and then for breaks I would look for UFO films on YouTube. YouTube was a different beast back then, and the Hutchinson effect, some of it's just been wiped off. Or it's maybe you know, it's restricted. I should learn VPN. Maybe I can find it that way.
That's strange.
Well,
Yeah.
I mean, Hutchinson might be able to help find the lift up off frequency. You know, there's, or you just, if he's in Portugal, wait until all the silliness in Europe's over and fly over. There's like, you know, I had, there's got to be something through your university where you can get travel funds. My UNM had one. It was great. Like, you go up there, it was in the, like, not the student union building, but the student services building or something. And they could fund you like a couple $100, like $800 or $1,000 for some of these events. So, or talk with the dean of your college. If you got a PhD, there's some way that you're trying to. Sometimes the teachers, yeah, Christos at UNM, he sent me to DC to attend the FAA conference. So it was cool. Like, use the university, man. You're still near it. You should be able to get over there. Go get some.
That big an issue. It's just Alex, he doesn't want people visiting him.
Well, I know, but you're like one of his disciples now. You have a machine that he made. So there should be some, you know, ask him, you know, why not?
Yeah, we've also tried to ask Alex to come here to the United States, and Mark agreed that, yeah, if he wants to come here, stay at Mark's lab.
That'd be cool.
Yeah, we're trying to arrange that. He might have changed his mind recently.
Привет, как дела, Алексей? Очень хорошо. Я говорю по-русски язык. I don't know if I am Russian. I'm almost fluent in. If I learned that at the ISDC last week and a couple of weeks ago now, and there were people there, professionals, some blonde, she was working on medicine and stuff. She had questions about the Havana syndrome. But yeah, you know, she was just blabbing away in Russian, and I was like, oh, totally understood. It's kind of neat. So, Alexei, привет. Поход, no, поход, that's hike. Самолете. I'll remember. There's certain words I don't have anymore, but get on the plane, man.
Right. Yeah, and Mark offered, you know, Daria to help translate as well, and we have Mikhail from Russia that might help translate.
Oh yeah, you'd be amazed. I think like your iPhone and the little AirPods now are almost like instantaneous translation, right? I mean, there's something like that out there.
With the universal translator from Star Trek
It's
is in your phone right now.
Your AirPods, yeah. Anyway. Oh, you know, some people got to work on holding the world together.
Yeah, and the craziest thing is, while they're translating, they're also feeding their metadata to the Google searches. So, so if you talk to aliens about bismuth magnesium, they'll try selling you it with directed ads.
So on APEC, has no one come with a proposal for a teleportation system?
No.
They consider propulsion, or?
No. No, I'm just out of curiosity, you know, because I know there's research going on in that area, but you know, they've done it in the lab, but you know,
I don't think it's on there yet.
The Tear in the Sky documentary, where they just saw the alleged wormhole.
a wormhole. Oh, okay.
It's a new documentary out. Will Shatner and Michio Kaku. And,
Did anything come out of it? I mean, was that a travel portal or?
yeah, it looks like tickets were in there, and maybe a TikTok.
When they went to San Clemente Island and set up all the equipment looking for stuff. And
Yeah, that was Christopher Altman, I think, right?
yeah, there was lots of hype, and all they found was a cloud that disappeared.
I'd say it was
Yeah.
more
So they call it a tear in the sky.
tear. Yeah.
Yeah, there's a lot of movies like that.
Well, at least they were intellectually honest and showed us what they found, and didn't make shit up. I appreciate that.
Yeah, if you, I was telling Jeremy in the comments, yeah, if you go to their UAPX website, they gave updates after the documentary of some of the details. Like one of the IR cameras went out, and in the documentary, they thought that was a EMP effect from the UAP, but it ended up being they forgot to plug in the power, so the batteries died all in unison.
You know, I mean, that's the reality of testing stuff, right? Is, you know, especially with stuff like that, you're looking for something that's kind of an anomaly and an exception by definition. So it doesn't surprise me really, you know, and I don't think that's a bad thing. It's just like, okay, better luck next time, right? You know,
Problem,
mean-
yeah, releasing the documentary, they only had that one.
yeah, it's
And
like you go out looking for Bigfoot. Maybe you'll go where he's been, but you know, just what are the chances that you're going to see him? I mean, it's the same. You know what I mean? So I don't know.
Yeah, that was interesting. They decided not to try to guess at what they were seeing. They just wanted to present the data.
Yeah.
Pretty good.
Well, guys, have we just about wrapped up today's conference, do you think? Or yeah. Well, let me stop recording then, and I will do that now. This has been one heck of a conference.